you are going to encounter some problems in your thought primer homework that are a little bit trickier than the ones we've been working on so far, and you're not going to be able to use that really straightforward approach to solving those problems. Aren't you thrilled to learn that? Okay, so what we're going to do in this thought primer, in this lecture, is we're going to explore some strategies for dealing with those problematic problems. All right. So here we have three compound statements, and each one of these compound statements has a main operator that indicates the truth value of the entire statement. We also have a set of knowns. We know A is true, we know B is true, we know Y is false, and we know Z is false, and we know that P is unknown. So our task is to see if we can deduce the truth value of the main operator for each of these three statements using our known truth values. Okay? Now the main operator is going to have one of three truth values. It's going to be true, or it's going to be false, or it's going to be impossible to determine logically with 100% certainty, in which case we say it's logically undetermined. Okay? So what you're going to do is you're going to pause your video and you're going to use those known values to try to deduce the truth value of the main operator for each one of these statements. And I'm going to give you a hint. We're going to turn this into kind of a game. None of these statements has the same truth value as any of the others. In other words, one of these statements' main operator is true, one of these has a main operator that's false, and one of these has a main operator you are not going to be able to determine the truth value for. Isn't this exciting? All right, so why don't you go ahead and pause your video, see if you can deduce the truth values for each one of these three statements, and when you're ready to check your work, go ahead and restart your video. I'm going to wager two things. One, you're really frustrated with me because I told you there's only one of these statements that has a truth value of logically undetermined, and you think there's two. See if I'm right. Okay, so here's our first statement. What do we know? We know that A is true. We know that Z is false. We know that P is unknown. We also know this. The main operator of this statement is this horseshoe outside of brackets and parentheses. Okay, there's our main operator. That's ultimately our goal, is to determine the truth value for that operator. And we also know this. Here's another thing we know. We know that the truth value of the main operator is going to be determined by the truth value of the horseshoe here in parentheses and the truth value of Z over here. Now the problem is, we don't know what P is, and if we don't know what P is, how do we know what the truth value of this horseshoe is? Okay, and when we encounter this situation, one strategy we can employ is just to assume that P has a particular truth value and then see what happens. Okay, so let's just say we assume that P is true. Now we can look at our conditional statement graphic here and find the line that seems to reflect what we now see for this statement in parentheses. The left-hand side is true, the right-hand side is true. That looks exactly like line 1. And when that's the case, the horseshoe itself is true. Okay, so now that we know the truth value of the horseshoe and we know the truth value of Z, we can look back at our graphic and find the line that matches that combination, and we see that when we assume that P is true, that main operator horseshoe is false. But we don't know that P is true. We just assumed it to see what would happen. What we have to do now is we have to try deducing truth values again, except this time we're going to assume P is false and see what happens. Okay, so when we assume P is false, we look on our graphic here to see where the left-hand side is false and the right-hand side is true, and we see that right here on line 3. That tells us that in that circumstance, this horseshoe in parentheses is going to be true. And now we can look again at our truth value of the horseshoe, truth value for Z. We're right back at line 2. The horseshoe is false. Okay, so what did we learn here? We learned that for this statement, it doesn't matter what the truth value of P is. If it's true, if it's false, doesn't matter, because the main operator horseshoe is always going to come out false. And that means that we can, with 100% confidence, say this statement is false, even though I don't know what the truth value of P is. All right, let's look at the second problem here. P horseshoe A, we know that A is true. We know that P is unknown. Now, we could go back and do the same thing that we just did. We could run it once, assuming P is true, run it another time, assuming P is false, see if we have the same thing happen where the value of the horseshoe comes out the same both times. But we could also do this. We could just look back at our conditional graphic here and look at the lines 1 and 3. On line 1 and 3, the truth value of the statement on the right-hand side of the horseshoe is true. But the truth value of the statement on the left side of the horseshoe is true on line 1 and false on line 3. And notice that on both lines 1 and 3, the horseshoe is true. What does that tell us? Tell us it doesn't matter what the truth value of P is. This statement is always going to come out true. In fact, any horseshoe statement, any conditional that has the truth value on the right-hand side as true is going to come out as a true horseshoe. We don't even have to know what the statement on the left-hand side of the horseshoe is. All right, so we know this statement's true. That takes us to our last statement, A, horseshoe P. Again, we know that A is true, P is unknown. When we look at our conditional guide, we can't do the same thing that we just did on the previous problem, because we see here that when on lines 1 and 2, the left-hand side of the horseshoe is assumed to be true, and the right-hand side has true and false values, and that makes a difference here. Okay, the horseshoe is true on line 1 and false on line 2. So that means we're probably going to have to go back to what we did with our very first statement, and that is, let's try it assuming P is true and see what happens. When we assume P is true, we can see on the first line of our conditional graphic that the horseshoe is true. But again, P is not true. We just assumed it to be true. So we're going to try to deduce values again, this time assuming that P is false, and see if the same thing happens that happened with our first problem. Okay, so now we assume P is false. Now our arrangement of truth values for our statement is reflected by line 2. And line 2 says when the left-hand side of the horseshoe is true and the right-hand side of the horseshoe is false, the horseshoe is false. Okay, that means the truth value of P really matters, because if P is true, our statement is true. If P is false, though, our statement is false. And we don't know whether P is true or false. We just know it's one or the other. And that's what causes us to say this statement is undetermined. There's no way to know the truth value of the main operator without knowing the truth value of P.